So our question of interest was, on average, does the UICCP female perform more than 7 push-ups? So we're going to create a confidence interval at 95%. So we're going to start with our hypotheses. So it'll be HO, and then mean is equal to 7, and alternative would be the mean is greater than 7. And then we have to state what mean represents. So where the mean represents the true mean of push-ups that a UICCP female performs. Okay, once we have that, we have to state our conditions. We have our randomization condition. And here we have to state that the 10 females were randomly selected, and we conducted a SRS using all the data from all the UICCP students, and we picked we used a random number generator, and we picked 10 females. Randomization is important because we want the sample to represent the actual population. We use the 10% condition to ensure that what we take is an actual sample. So we have to state that the 10 females surveyed is less than 10% of the total population. Okay, and then our last condition is that n, which is 10 in our case, is less than 30. And with this, therefore, we can assume that the distribution is roughly symmetric and unimodal, and we can use a t-distribution to conduct a one-sample t-test. And in order to make sure that we can conduct a one-sample t-test, we have to create a histogram. And once we plot everything into our calculator, we will get a histogram that looks like this. And although the distribution is not perfectly symmetric, a one-sample t interval will be constructed because the population standard deviation is unknown. Okay. Okay, so after this, we're gonna move into our mechanics. So we have x bar plus or minus t, and then we have our standard deviation, which is as x bar over the square root of n. Before we can go on with this, we have to make sure that we do not have any outliers, so we conduct the 1.5 outlier test, and we do so by having so we have Q1, which is equal to 1, and Q2, which is equal to 2. And so we do 2 minus 1, which is equal to 1, and then times 1.5, and that gets 1.5. So then we have Q3, so we have 2 plus 1.5, which is 3.5, and then we take Q1 minus this answer, so it would be 1 minus 1.5 is equal to negative 1.5. So our upper bound is 3.5 and our lower bound is negative 1.5, and this resulted in we had to remove 2 of our data points because they were out of our bounds. And okay, so now we have that, we can move on to the mechanics. So we have our x bar, which is equal to 1.625. We get this from our calculator. and then we have to find t, so we do inverse t. And since we're doing 95% confidence, we have 97.5 here, and then our degrees of freedom, which is 7, because n minus 1 is equal to 7. Once we have that, we have a result of 2.36. And now we have to solve our standard deviation. And we have 5.18 over the square root of n. And once we conduct the test, we have a result that is equal to, so our lower would be 1.923 and upper is 2.0577. Okay, and then we have to conclude, so we say that we are 95% confident that the true mean of push-ups that a UICCP female can perform is between 1.19 and 1.19 push-ups and 2.06 push-ups. And then going back to our question of interest, which was on average does the UICCP female perform more than 7 push-ups, our confidence interval shows that the average female performs less than 7 push-ups. The average would be between this interval that we solved for.
Today we'll be conducting a significance t-test. So first we have to state our HO, which would be mu equals 7. Next would be our HA, which mu is greater than 7. Next we state our parameter of interest, which would be where mu represents the true mean of push-ups that a UIC CP female can perform. After this, we would state our conditions. The first condition would be randomization. The way we found randomization was that we conducted an SRS, simple random sample, and we selected 10 females using a random number generator. After this condition, we had to state that the 10 females is less than 10% of the population of females at UICCP. The reason we had to state this condition is in order to show that it's a sample. the last condition would be that n is less than or equal to 30, which in this case it's 10. Therefore, we can assume that the distribution is roughly unimodal and symmetric. When we plugged it into our calculator, we found that the histogram looked like this. So therefore, although distribution is not perfectly symmetric, a one sample t interval will be constructed because the population standard deviation is unknown. So from here, we'd have to find our standard deviation, which is sx bar. We do 1.58. We do 0.5818 over the square root of 8 being the n value, the sample population, which is n being the sample population. We would have to subtract two data points due to the fact that they didn't pass the outlier test, the 1.5 outlier test. From here, we'd have 1.8. So we do t of 7, which is the mean, and then that is our standard distribution. So from here, we would due to these what's called conditions, we would do a one sample t test. We'd be able to do a one sample t test. From here, we'd find the t-score by the sample minus the pop. And this would be our sample we found that was 1.625. And then due to our null hypothesis, the population would equal 7. And then we would use the standard deviation that we found over here below this one. And from here we found that this equals negative 29.3716. So after this, we would, since we have a sample population of 8, our degree of freedom would be 7. And the distribution of, since it's less than 30, the graph would look somewhat like this. Somewhat like this, with this being the 5% significance. And then our mean being 7 with our sample x of 1.6. And from here we would do TCDF of negative infinity, and then we would plug in our t-score of negative 29.3716, and then our degree of freedom, which would be in this case 7. So after plugging that in, we would get 6.8286 to negative 9, to e to the negative 9, which is approximately 0. So P T is approximately 0. So lastly, we have to state in context, which is since the p-value is approximately 0, is less than 0.5 significance, we reject the null hypotheses. We have sufficient evidence to conclude that the average UIC CP student, female student, does less than 7 push-ups.
Okay, and to conclude properly, we want to figure out, do the results of the confidence interval and the significance test match? We would have to go back to our question of interest, which was, on average, does the UICCP female perform more than 7 push-ups? With our confidence interval, we saw that the true mean of push-ups that a UICCP female can perform is between 1.923 and 2.057 push-ups. And our significance proved that that we reject the null hypothesis, which is that the UICCP performs 7 push-ups. So the results did match. We concluded today that the average UICCP female performs less than 7 push-ups. To improve this study in the future, we would want to take a bigger sample so that the data is more representative of the actual UICCP population. Thank you.